Just wanna take a chance, never let go of your hand. Travel to the stars and back with you. On another moonlit night, can you feel the magic here tonight? Yeah, we're seen to fly, hearts like yours and mine, always beating perfect time to the music of a moonlit night.
Welcome, everyone, to NASA's International Observe the Moon Night broadcast. I'm your host, Andrea Jones, and I'm here at NASA's Goddard Space Flight Center in Maryland to help guide you through a great program. International Observe the Moon Night is a day each year that we invite everyone on Earth to observe the moon, to learn about the moon, and to honor the cultural and personal connections we have to the moon. It's a day to catch up on what's been happening in lunar science and exploration, to celebrate the moon in our arts and culture, and for lunar enthusiasts around the world to connect. This is our 13th International Observe the Moon Night, and we are so glad that you are here with us. While you're watching, or after the broadcast, you can check out our website, moon.nasa.gov/observe. Here you'll find lots of information and resources, some creative observing ideas, because you can observe the moon with senses other than sight, and our map of lunar observers around the world. You can add yourself to this map by registering. You can also find out how other people are participating and share your own pictures and experiences in the International Observe the Moon Night Flickr gallery, and by using the Observe the Moon hashtag wherever you are on social media. International Observe the Moon Night was inspired by events celebrating the arrival of NASA's Lunar Reconnaissance Orbiter and NASA's Lunar Crater Observing and Sensing Satellite, or LCROSS, at the moon in 2009. Since then, LCROSS has successfully completed its mission, and LRO continues to teach us new things about the moon. I'm going to pass things over for the project scientist for LRO, Dr. Noah Petro, who will give us an update on what's been happening with the spacecraft and the mission.
Hi, I'm Noah Petro, lunar enthusiast and project scientist for NASA's Lunar Reconnaissance Orbiter, a spacecraft we call LRO. Imagine for a moment you're about to take a long road trip. What sorts of information might you want to have before you go on that trip? You probably want to know the path, the route that you'll take. You'll want to know where you can refuel, and you want to know where you can get out and stretch your legs and take in the view. Well, in 2009, NASA sent LRO to do just that for the moon, to create a high-resolution digital atlas of our nearest neighbor in space. On LRO, we have instruments that collect high-resolution images, map the topography of the moon better than any other object in the solar system, and tell us where those valuable resources exist at and near the lunar surface. In short, LRO has ushered in a completely new era in our understanding of the moon, how it changes, and how it existed maybe 4.5 billion years ago. With this data, we're prepared for a new generation of lunar explorers to get back to the lunar surface. Both human and robotic explorers will use the data from LRO to not only safely navigate the lunar surface, but conduct some of the most sophisticated science investigations of any planetary surface ever. Now, what do you do when you've done all of those exciting things at the moon? Well, you prepare for other explorers. And over the next 3 years, LRO has a new mission in store. So let's learn a little bit more about that mission by watching this video. Let's take a look.
This year, the Lunar Reconnaissance Orbiter celebrates 13 years of orbit around our moon. And in that time, it has collected over a petabyte of data, the largest volume ever collected by a planetary science mission at NASA. Due to its success and continued operational abilities, NASA has awarded the spacecraft an additional extended mission phase so that it can continue gathering critical information on the moon and help pave the way for future lunar missions. Going forward, the LRO mission will have 4 main areas of focus. The first is the study of volatiles, which are chemicals that easily evaporate or vaporize, such as water. In terms of lunar exploration, volatiles will be useful for things like creating rocket fuel and making oxygen to breathe. so they are a primary resource that future astronauts will depend on having. LRO will continue to provide new data for identifying which areas are rich in volatiles, and for cluing us in to how they may move around the lunar surface. Current LRO data suggests they may be frozen in permanently shadowed craters, in areas that receive some sunlight, and may be chemically locked in minerals on the moon. This is helping pave the way for future missions like Viper, which will send a robotic rover to explore an area near the lunar South Pole, and ultimately, the astronaut-led Artemis missions. The second area of focus is on the moon's interior, volcanic features, and the tectonics of the moon's surface, because understanding the lunar surface requires knowledge of what's been going on underneath. Scientists want to figure out when the moon was last volcanically active, and how current geologic processes, like moonquakes, could affect the safety of future exploration. They'll do these things by studying lobate scarps, as well as deep crustal and mantle composition that are exposed at the surface. Studying the moon's history of volcanism and tectonics will also inform us about other planetary bodies in our solar system and beyond. The third area of focus is on the moon's surface, its regolith and impact craters. We want to know how impact craters break down, and if different ejected materials might degrade at different rates. These studies will give us a better understanding of the mineral and chemical makeup of the lunar surface and subsurface. This information can tell us how the moon has changed over hundreds of millions or billions of years. Studying the moon's regolith and impact craters also informs scientists about space weathering, which can help similar studies looking at the Earth, as well as on places like Mars, Mercury, or even asteroids. The last focus area for LRO going forward is support for future missions. NASA has plans for numerous missions to go to the lunar surface during LRO's extended phase. Sending missions to the lunar surface requires planning, not only to build the mission, but to find safe and interesting landing sites. LRO is in a unique position to directly assist with some of those operations and science objectives. LRO can help identify landing sites by making maps that tell us what the surface is like, where there may be hazards to landers, and where there are interesting features to explore. LRO is also capable of helping landed missions get simultaneous measurements from orbit while they gather data from the surface. After studying the moon for 13 years, LRO has proven to be one of NASA's most valuable tools for advancing lunar science. And as it continues collecting data, the spacecraft helps lead the way for future exploration of our moon.
Hi, I'm Surby. I'm Zoe.
I'm Ben.
I'm Chloe.
And I'm Samuel.
And we are
Amateur astronomers.
We are currently observing from Roundwood, County Wicklow, Ireland's highest village. Here's how we observe the moon.
Or as we say in Irish, ag fécint ar an Ialach.
We
are ready for Artemis.
Hi, I'm Mary.
I'm Erica,
And I'm Frank.
and we're from the Center for Astrophysics, a collaboration between the Smithsonian Astrophysical Observatory and the Harvard College Observatory.
Our favorite way to observe the moon is with the Micro Observatory Robotic Telescope Network, a network of telescopes like this one in Cambridge, Massachusetts.
We also have telescopes in Arizona and even Chile.
So join us observing at microobservatory.org. Choose Observing with NASA portal, select the target moon, and an email of your picture of the moon will arrive the next day. So join us.
Hello everyone, we are the Milkweed Choir from South Africa.
And we are so excited to be celebrating the International Observe the Moon Night with NASA!
Welcome back. The moon is near first quarter today, which means you can find it in the afternoon and evening sky. It's a great phase to observe the moon through a telescope or pair of binoculars. The line between day and night, which is called the terminator, is a great place to see the rugged lunar terrain really pop out. There are long shadows from crater rims and mountain peaks that are as high or higher than what we have on Earth. With a telescope, you can catch glimpses of volcanoes, fractures or big cracks in the moon's surface, and even winding channels carved by lava. But you don't need a telescope or pair of binoculars to observe the moon. With just your eyes, you can see dark and light patches. The dark patches are plains of solid lava called maria, the Latin word for seas, and the light patches are the rugged lunar highlands. There's a lot to learn from observing the lunar surface. Take a look at this next video for a view of an interesting sight.
Ariades Rill is one of the moon's best examples of a straight rill. Running roughly east to west, it appears as a great fracture in the lunar crust, measuring about 220 kilometers long, 4 kilometers wide, and 0.8 kilometers deep. This is an example of a graben, where a long block of land drops down between two parallel faults. It may have been formed by a rising dike of magma wedging open a crack in the lunar crust.
Studying the moon allows us to peer back into history in a number of ways. By studying the moon's geologic history, we can learn about its formation and what happened over time, as well as about the geologic history of the Earth and other moons and planets in our solar system. NASA's Apollo program made history by bringing the first humans to the lunar surface, allowing us to experience firsthand what the moon is really like. This year marks the 50th anniversary of Apollo 17, which was the last of the Apollo missions to visit the lunar surface. It's an incredible milestone, and this next set of videos will help us see how that history connects with our current exploration of the moon and what is coming in the future. Take a look.
Later this year, Apollo 17 astronaut and geologist Jack Schmitt will mark 50 years since his first steps on the moon in December 1972. Those footprints left an impression on both the moon and on Schmitt.
No matter how much preparation you have for experiences like stepping on the moon, it's going to be more than you ever anticipated.
Schmitt was the first trained field geologist to observe the moon up close and personal, and he found himself discovering unexpected things with every step.
Every rock that we examined had something new that I didn't expect, and surprises is what geologists like. That's why you're exploring, is to see the things that nobody's ever seen before.
Schmitt spent a combined 22 hours outside of the spacecraft during his 3 excursions on the moon. Before his own trip, Schmitt trained other Apollo astronauts, sharing with them his in-depth knowledge of fieldwork.
The main thing was to expose them to as many different, say, geological experiences as we possibly could. Get them out in the field. Don't let them sit in the classroom.
He treated training scenarios on Earth the same way he would if they were on the moon, including simulated equipment, backpacks, and cameras strapped to the front of spacesuits. Astronauts could then focus on what differences in the rocks they were seeing and what rock samples were best to collect, essentially giving them the fundamental field geological experiences that they needed to succeed. The 4 or 5 days per month Schmidt spent training astronauts in the field really did make a difference.
The quality and diversity of the Apollo sample collection, independent of Apollo 17, where you had an experienced geologist, the quality and diversity of that sample collection is just remarkable.
Fortunately, the current Lunar Reconnaissance Orbiter mission, or LRO, is changing the game, bringing back high-quality photography of the moon that Schmidt only wished he'd seen before his own trip.
The Lunar Reconnaissance Orbiter program now has provided us with a much, much higher resolution suite of photographs for any future astronauts.
What we learned from the Apollo missions helped lay the groundwork for LRO, and LRO will help guide future explorers.
Every new environment in which a geologist works is usually very different than the last, but you have learned things from your previous experiences that do in fact enable you to maximize the value of your new experience.
Schmidt has his fingers crossed for future moon exploration, a landscape he considers holds answers to many questions about the early solar system.
You can hear people talk about it, but you can't absorb it until you're there.
Apollo 17, the final Apollo mission to land on the moon, visited the spectacular Taurus Littrow Valley, deeper than Earth's Grand Canyon. In December 1972, astronauts Gene Cernan and Jack Schmidt explored an active fault scarp, a gigantic landslide deposit, and brought back samples including beads of volcanic glass erupted in an ancient lunar fire fountain. Schmidt was the first professional geologist on the moon.
So we received samples from the Apollo 17 mission, which were returned to Earth in December of 1972, so nearly 50 years ago.
Basically collected on the moon, brought back, then they were frozen within about a month of being returned, so no one's ever looked at them since. It's very exciting.
A curation facility at NASA Johnson Space Center sent us the samples, and they did have to do some special efforts to keep them cold because we wanted them to stay frozen. So they had a special cold shipping box with panels that were frozen in a very cold freezer and a chunk of dry ice. We picked it up from the receiving office here at Goddard, opened it up, pulled the samples out, and stuck them straight in our freezer and locked them up safely.
So these frozen samples were actually collected from a region on the moon that was in shadow from the sun. So it was basically a large boulder. In the near future, we're going back to the moon and hopefully going to the polar regions of the moon, where some of these regions are in permanent shadow and they don't see the sun, you know, they're cold. These particular samples are really great analogs for what we might expect to see in the polar regions when we go back.
So we actually started last week to process the samples. So the samples we got are basically dirt, lunar dirt, and we basically made moon tea out of them. So moon tea is what we call it when we pull out the soluble compounds from the soil. And so we basically take the lunar sample, seal it up with a torch in a little glass test tube full of water, stick it in an oven overnight and boil it, and we're just pulling out those soluble compounds that we care about, the same way you'd make tea with boiling water at home.
What we're trying to do is answer some questions about the history this sample experienced at the surface of the moon. The surface of the moon is a really hostile environment. You know, it's not like here on Earth where we have this beautiful atmosphere that protects us from the nasties of space. So we have particles from the sun that are continuously hitting the surface of the moon, and we've got galactic cosmic rays that are coming in and penetrating into the surface as well. They actually create noble gases in these particles. So you can imagine that there's none to begin with, and then as they get exposed to this space environment, they kind of get more and more buildup of noble gases. And our technique is to actually unlock those noble gases from the sample and measure them so we can come up with what we call a cosmic ray exposure age. So it's basically how long this sample has been sat at the surface, being exposed, so basically getting a space tan. Say 50 years ago, this same technique, which is called noble gas mass spectrometry, would probably need anywhere, tens to hundreds of milligrams to do the same thing that we now do with a couple milligrams.
It's really special to be part of this, and particularly because I can look back at the papers and the processes that the curation office and the scientists in the 1970s thought about, and they put so much care into preserving these samples for future science, to making sure that they were going to be at the best conditions, so that as we develop new techniques, we're able to go and look at these samples and get new answers to the science questions that were being asked.
I'm still studying these samples 50 years later from the Apollo mission, the original Apollo missions. And, you don't know what's going to be in another 50 years, but I'm still a part of the Apollo dream of going to the moon and bringing samples back. So the fact that we have Artemis now is amazing. Like, having our own Artemis generation is really exciting. I just can't wait to see people go back to the moon.
NASA's Astromaterials Research and Exploration Science, or ARES team at the Johnson Space Center in Houston, Texas, is responsible for curating the agency's Apollo lunar samples. Studies of these moon rocks continue to unveil discoveries about the moon and our solar system, but also help prepare for the return of samples collected during future Artemis missions. Recent work by our team on samples such as the Apollo 17 core seen here supports the Apollo Next Generation Sample Analysis, or ANCSA, initiative. This initiative has enabled a new generation of explorers equipped with new and improved technologies to study Apollo samples. ANCSA helps link generations of lunar explorers and has also enabled our team to capture valuable lessons learned that can be applied to collecting and curating moon rocks from Apollo to Artemis. Let's take a look at how NASA got samples from the moon.
Tranquility Base here. The Eagle has landed. Oh man, look at that rock out there. Absolutely incredible.
Apollo samples may have been collected 50 years ago, but new and exciting research is ongoing. Seen here is the Apollo 17 core sample that was vacuum sealed on the moon. Earlier this year, almost 50 years later, the team members seen here were involved in a successful extraction of gases from the core sample vacuum container. The many lessons learned from this process will be applied to the future collection of volatiles, which you can think of as gases from water or hydrogen or carbon dioxide or others that we hope to collect during Artemis missions. The team also carefully processed lunar material collected in the Apollo 17 core from below the lunar surface, carefully separating out individual pieces of various sizes and documenting every step taken throughout the process. Utilizing technologies such as X-ray computed tomography, or XCT scans, which you can think of or think about like scans a doctor may take of your brain or another part of your body to see what it looks like without doing surgery. Well, these types of scans provide exciting data valuable for research, but scans of the vacuum-sealed Apollo 17 core proved to be extremely valuable in the successful gas extraction and processing. These lessons learned again will be applied to the collection and curation of future samples. Lunar exploration and investigating moon rocks is exciting, and individuals of all ages can get involved. One way is to check out our Astromaterials 3D lunar collection. Astromaterials 3D allows an individual to explore a subset of samples collected from the 6 Apollo surface missions. You can select a mission, find a sample of interest to you, and then open that sample and explore it further. As you further explore the sample, you can interact with the sample, or you may decide to explore it even further using our Explorer tool. The Astromaterials 3D Explorer allows you to interact with the sample, looking at it in different lighting conditions, or even allowing you to view it in 3D. Now, as you wear 3D glasses and explore this sample, it's as though the sample is jumping out of the screen and into your hands. Now, thanks to XCT scans of each sample, again, think about a doctor taking a scan of a part of your body, you can actually explore the interior of a sample, in a sense, slicing into it and finding interesting features. There are lots of other details available on the site, but one additional aspect to point out is that you can even download and print your own 3D model, which can also be fun. Now, additional resources we have available are our Classifying Moonrock Interactive.
That's one small step for man, one giant leap for mankind.
This online interactive allows learners of various ages to get introduced to our lunar lab, build background, as well as skills enabling a user to learn how to classify moon rocks as well. Users can also learn fun facts about the samples, as well as fun facts about each of the Apollo missions and so much more. The interactive encourages users to continue their journey of exploration with connection to views of landing sites, as well as Astromaterials 3D and more. We encourage you to take advantage of the many ways to explore the moon, including looking up at the night sky, but also exploring and interacting with the moon rocks in our collection using resources we have available on our website. We hope you, as we are excited about the journey back to the moon as we continue to learn from Apollo and look to the future with Artemis and the future collection and curation of moon rocks.
みんなで月を見よう。I'm focusing on the moon because humans will be expanding the area of activity in the near future. I have been supporting it from the aspect of running site analysis using observation data. Let's look up the moon and imagine humans walking there again.
Nazywam się Kinga Ruszecka i zapraszam do wspólnej obserwacji Księżyca.
Nosotras somos como la luna. Cada fase es un cambio para llegar a nuestra plenitud. ¡Viva la noche de observación lunar!
Hey, we're the 2022 Winter Over crew at the bottom of the world, observing from the National Science Foundation Munson Scott South Pole Station here in Antarctica.
In Spanish, we say Observe la Luna.
In French, we say Observe la Lune. South Pole Station's looking forward to Artemis 1 launch and NASA going back to the moon.
Woo! If I go to the moon, I'd bring some crackers just in case it's made of cheese!
Woo!
Hello again. I hope you're enjoying this International Observe the Moon Night broadcast. As a reminder, you can visit our website, moon.nasa.gov/observe, where you can find resources, activities, viewing guides, and more. Lots of things to help you learn more about the moon and enhance your experience participating in International Observe the Moon Night. Now, the moon has been an important marker of time for humans for tens of thousands of years. It's an important part of the creation stories in cultures around the world. It's woven into our language and our art. Today, the moon continues to inspire poets and painters, artists and dreamers, scientists and explorers. Next, we present some moon poetry and also some beautiful views of the lunar terrain that we hope will inspire you.
A brief history of the moon. When the moon rises, it's where you are. Light reflected from the sun shines in your eyes. Your skin beneath the moon is a long skein of stories too many here to tell. But there is a man stooped fishing beneath a banyan tree there, and a precious elixir somewhere in, perhaps, the snow-white south. They've said all that's lost on earth gathers heaped up there on what they've also said was our mirror. Inanna rotting monthly on a hook, global goddess, arrowed, lonely, dark, full, and the children are singing, guard me till you die. Your heart brims with moonlight because you love and are loved, changing moods like shapes that cross the sky, and someone in a cave once etched phases on antler to keep time. We had to know. Silver falling through clear or clouds ringed like caution against the thief. Night road, moon road, a destination reached. A village, or metaphorically say, the moon itself, drawn down from heaven by the telescope. Not spirit smooth, but rock. You, tonight's Galileo, can see time, collision born, craters, mountains shocked up to snare sunlight on the night's ragged edge, valleys of dust and boulders radiating from Maria. Just by looking, the moon is yours, where you are, living magnified by this lunar span.
I'm Julie Swarstad Johnson. Nocturne with Freeway. The day having taken itself off, unruly as the mass of feral cats who have lately made my yard their own, the moon lifts up from behind Reddington Pass, from behind domed mountains, behind the overpass, the mound of asphalt massed up so Broadway can be widened after years of debate and alternate proposals and whatever it is that keeps us from choosing well together. The moon rules over all this. I don't know if it's full or a day past, maybe one to go, my mind eager to fill in what's missing. It matters to me, here in all I lament and praise, the city's million dreams surrounding me. I want the precise name for this moment's shine, a measure of all that does not pass through me.
The future of lunar exploration is as bright as the moon in our night sky. NASA is gearing up to return humans back to the lunar surface with the Artemis missions. We'll be exploring the moon's south pole, looking for water ice with the Viper rover, and with Vertex, we'll explore a feature known as Reiner Gamma, an area that has beautiful white swirls and a very strong and mysterious magnetic field. The women and men serving as the scientists, engineers, and astronauts for these missions are all helping us take the next giant leap forward in better understanding our moon and our universe. There's a lot on the horizon, as you'll see in these next videos.
Artemis 1 is paving the way for us to explore deeper and deeper into space.
I think Artemis 1 is significant on so many levels. It is a new frontier to do science.
So the primary objective is to test the Orion spacecraft integrated with the Space Launch System.
And it is designed to carry out the boldest of the bold missions.
But it's more than just learning how to travel in space. We're taking a lot of cool science along with us on this first mission to the moon.
So as NASA plans to go back to the surface of the moon and then onto Mars,
we want to spend more time there, and that's riskier business. So the more we learn about the moon itself and the environment where we'll be operating, the better we can prepare. We have 10 CubeSats we call secondary payloads, which are small scientific spacecraft of their own that will each be conducting their own scientific mission.
All of these payloads in some form or fashion will help us going forward. They are going to be studying the moon.
And they're going to help us understand what is the moon made out of, what types of rocks, what types of regolith, what types of ice, what's mixed in with water that might be present.
One of them actually is going to attempt to land on the moon. They're going to be studying the sun.
Understanding and studying the space environment or the space weather.
Some different propulsion systems. These novel ideas will ultimately turn into the technology and the systems that we want to use going forward.
There's a lot of cool things going on between all these CubeSats that make up our secondary payloads. Additionally, inside the Orion, we'll be flying an experiment to study space biology.
Space biology is where we study the underlying changes that Earth-based biological systems undergo when they're in space.
Or basically, how does life respond to the space environment?
The level of ionizing radiation that you experience when you go beyond the Van Allen belt, so you go beyond the protective magnetic sphere that we have around us, you then get exposed to higher levels of ionizing radiation. So we are flying several space biology experiments.
We will take a series of materials,
plant seeds, fungi, the yeast cell, algae,
and ride along the trip. And then when it comes home, we can analyze how they responded to that environment.
This research will help us thrive in space. It will help us to go further and stay there longer.
In addition to space biology, we'll be learning about how to make astronauts more effective in the Orion in the future. An example of that is something called the Callisto Technology Demonstration.
Lockheed Martin built the Orion spacecraft for NASA, and we'll be flying a secondary payload that's a demonstration payload called Callisto. So we took the technology from Amazon for Alexa and the WebEx technology from Cisco, and so we built a digital assistant, if you will, the custom space-qualified Alexa.
Alexa, how does the life support system work?
Orion's life support system is the environmental control and life support system oracles.
And so this payload is a demonstration mission to show how astronauts in the future could use this technology as an innovative user interface.
So there you have it. I hope you agree with me. This is exciting.
I am just over the moon excited.
The science we'll conduct on Artemis 1 lays the groundwork to ensure that we can safely conduct scientific activities at the moon with our astronauts going forward. This really is the stepping stone for us as we take that next giant leap in space exploration.
Artemis is our 21st century return to the moon. Together, NASA, international space agencies, and a growing global space industry will explore Earth's nearest neighbor with advanced robotics and our next generation of astronauts. But where will our astronauts explore? The moon is a treasure trove of scientific discovery, and NASA has its sights set on the South Pole. This mysterious region features soaring mountains and deep craters, leading to unique locations that experience nearly continuous sunlight, in contrast to nearby depressions that never see the sun. Artemis 3 will mark humanity's return to the lunar surface for the first time since 1972. NASA has identified 13 regions near the South Pole that meet safety requirements for landing and present opportunities to search for lunar resources. Each region can also help us learn more about the history of the moon and gain a better understanding of our place in the solar system. These 13 candidate landing regions represent a diversity of features in the lunar South Pole, ranging from the summits of mountains rising miles above their surroundings to the rims of large craters. These features together act to both expose and preserve billions of years of geologic history. Using robotic orbiters and rovers, NASA and the global science community will continue to study these regions before selecting the Artemis 3 landing site. The astronauts selected for this bold expedition will literally and figuratively shine a light on some of the deepest, darkest areas of the solar system, revealing ancient secrets of the universe.
The goal of the test here at the Slope Lab is to test the latest Viper mobility prototype in this facility in order to verify requirements. That means we want to check that the system does what it is supposed to do once on the moon. The Viper test unit that is behind me is a light version of the full Viper rover. We strip down the heavy components to try to maintain the mass low so that we can drive on Earth, which has a much higher gravity. And we need to do this because the system is designed to go to the moon where it will be a lot lighter.
We have consulted NASA scientists who have analyzed images and data from previous Apollo missions to determine the distribution of rocks and craters of different sizes over certain areas of the terrain and the shapes and characteristics of rocks that we expect to see on the surface. So what we've done is use that information to recreate a moon-like terrain for the rover.
We're testing our rover capabilities when we go into an extreme sinkage environment. So on the moon, when we're roving, we might encounter areas with fluffier soil, something similar to quicksand. And so our rover has a capability to still make forward progress in these quicksands. We're also testing the ability that the rover has to move in a very special way. It's similar to a caterpillar inchworming motion. So the rover is able to change the distance between its wheels and apply power to the wheels in a very coordinated manner, and that would allow the Viper rover to get unstuck of this quicksand.
This is challenging for the rover, but it's important to test because we need to better understand and mitigate risks and hazards to the rover. And we have a great team of NASA engineers here to address any risks that we might face.
Lacus Mortis, the Lake of Death, is a lava plain about 160 kilometers across. It was chosen as the first landing site for NASA's Commercial Lunar Payload Services program of robotic missions. Near its center is the crater Berg, 40 kilometers in diameter. West of Berg, Lacus Mortis's floor is broken by a fascinating network of fault scarps and fractures known as straight rills.
Welcome back. I hope you are enjoying the program, and I want to remind you that you can share your pictures and observations of the moon and find out what other people are doing to celebrate in our International Observe the Moon Night Flickr gallery and through the hashtag #ObserveTheMoon on social media. Each of us can observe the moon and come away with a sense of wonder and awe. We've asked some lunar scientists what excites them most about the moon, and here's what they had to say.
Hi, my name is Aisha Khatib. I'm a PhD candidate at the University of Maryland. I study lunar seismology, especially deep moonquakes. I'm really excited about the fact that we're going forward to the moon and we are trying to answer some of these questions that we've had for the past 50 years. What people might not know about the moon is that the moon is seismically active, so there are a lot of seismic events that occur on the moon. So just as the Earth has earthquakes, the moon also has moonquakes, and there are several different kinds of moonquakes that we've been able to observe from the Apollo seismic data. We have thermal moonquakes, we have shallow moonquakes, and we also have something that are really, really mysterious called deep moonquakes, which occur really deep down in the lunar interior. And we think they are due to tidal stresses, but we don't exactly know what causes these moonquakes. And I'm really excited about seeing new data finally after only working with data that's 50 years old. So that's what I'm excited about.
Hello, I'm Greg Schmidt, Director of NASA's SSERVI, the Solar System Exploration Research Virtual Institute. So one of the things that excites me so much is the discovery of volatiles. So what do I mean about that? You know, what I mean is that we have discovered things like water, you know, in the form of ice. Now, how it got there, we don't know yet. You know, a lot of people are still doing some pretty exciting research on that. There are other kind of materials that are preserved in these permanently shadowed regions on the moon that have been there for a really, really long time. I mean, we're talking billions of years. Why are they still there? Because it's so very, very cold. We're talking about some of the coldest places in the solar system, as cold or perhaps even colder than Pluto. And yet here they are on the moon. And so what's happened is that gases, water, other things have come into these shadowed regions. There's no sunlight for a billion years, perhaps more, and they get trapped there. And so what form they're in, how they're mixed in with the lunar regolith, as we call it, which is basically the dirt on the moon, how that's all mixed together, that's something that we need to find out, but it just presents some really exciting research opportunities.
Hi, I'm Lyndon Wyke. I'm about to enter my third year as a graduate student at the University of Maryland, studying planetary geology. I'm very excited about the moon right now because it serves as our first step towards exploring more of the solar system and the universe as a whole, but for the Artemis mission coming up, I'm very keen on seeing astronauts get to go back to the moon, forward to the moon for the first time in 50 years. So having astronauts go to the moon is also very important to me as it ties into my own research, where I've been looking into how to detect lava tubes as a resource for the astronauts and their equipment to use as shelter. When they get to the moon, when they say, we need somewhere to take shelter, and I'll be helping to find those.
I'm Carly Peters. I'm a planetary geoscientist. I'm a semi-retired professor from Brown University, but I've been working on lunar exploration and lunar science for decades, and I love it. Remember, the Earth and the Moon are related, more related than any other planetary bodies, and the moon affects us, sometimes directly, sometimes just because we can go out on a moonlit night and smile. It's an old friend, it's not going away, it'll be there for much longer than we are, and I love it.
Today, we've shown you a number of ways that we study the moon at NASA and why we're doing it. There is so much that we're still learning from our past exploration, and so many things that are happening now as we prepare for the next phase of lunar exploration with Artemis. The moon is a cornerstone for learning more about the solar system. It's a stepping stone for reaching Mars and beyond. Our accomplishments at the moon prove that nothing is beyond our reach. It's a symbol in the sky. So remember, no matter who you are or where you're from, you have the potential to dream big and reach for the stars. In that spirit, we bring you this next moon-themed music video featuring singers Javier Colon and Matt Cousin. I hope you enjoy it. That concludes our program for this evening. I'd like to thank the Solar System Exploration Division at NASA's Goddard Space Flight Center and NASA's Lunar Reconnaissance Orbiter for sponsoring International Observe the Moon Night. I'd also like to thank our incredible supporters around the world and each and every one of you for watching and for celebrating International Observe the Moon Night with us. You can keep up with lunar science and exploration throughout the year on moon.nasa.gov and by following NASA Moon on social media and by subscribing to our International Observe the Moon Night newsletter. You can sign up on moon.nasa.gov/observe. And that's the same place you can find the moon maps made special for today, activity recommendations, and find out where people are observing the moon around the world right now. And add yourself to the map. Thanks so much for joining us. Wishing you clear skies and see you next year.